Use the properties of logarithms to find the exact value. Now what I normally do is I set this equal to x. That's one of the ways of doing it, because that's what I'm looking for. And I just rewrite in exponential notation that 2 to the x is equal to negative 13. 2 to the negative 13. And we know if the bases are the same, then the exponents must be equal. You could always also use the inverse property. This is log base 2 of 2 to the 13. The log and the exponential cancel each other out, and you're left with negative 13. What's the base on this logarithm? What can I say this is the same as? Rewrite that log. What is it?
Log base 10.
Not like log base 10, it's the other one. Check your calculator face, that's a cheat sheet. Natural log is log base E. So this is log base E of e to the square root of 2. Now here, if I wanted to use the inverse property, log base E of e to the square root of 2 is just the square root of 2. And here I used the inverse property. And then here I rewrote and used and solved an exponential equation. Now here I don't have a choice. This is the inverse property. It's one of those times you don't have a choice. It's ugly. So this would be E, natural log as log base E of 8. Using the inverse property, base E and log base E cancel each other out, and we're left with just 8. And again, this is the inverse property. Sometimes don't have a choice. Now here what I need to do is I need to bring these together as a single log, and I can use property 1, which means that if I have a product turns, a sum turns into a product of the arguments. So this becomes log base 6 of 4 times, or 9 times 4. That's a new argument, which is log base 6 of 36. Now there's a couple of ways to solve this particular problem. I could say, okay, 36 is log base, is 6 to what power? 2. So this is log base 6 of 6 squared. Using the inverse property, this is 2. The other way I could have come at this is I could have said that log base 6 of 36 is equal to 8, or is equal to x. This says 6 to the x equals 36, so what's x have to be?
2.
Yeah, so this says that 6 to the x equals 6 to the 2, so that x equals 2. So that would be your second way of coming at it. So the inverse property can save you some time. I don't always see it that way. I normally do it this way, quite honestly. This says log base 8 of, now this is going to be the second property. I have a subtraction, and if the bases are the same, it says that the argument turns into a division because of this minus sign. So that this becomes the log base 8 of 16 divided by 2, which is log base 8 of 8, and log base 8 of 8 is log base 8 of 8 is 1. And that would be property 4. So this is property 4 in my list. This is property 2 in my list. This guy we use really frequently. Now here I've got this all stuff in the numerators or in the exponent. So this is 5. A sum turns into a product. Log base 5 of 6 times 7, which is 42. So this turns into log base 5. Whoops. This is 5 log base 5 of the product of 6 times 7. That's property 1. Which then turns into log base 5 of 42. Now this is where you have to be very careful. There's the line. There's the logarithm base 5. Notice this is a subscript here. There's still space between the line and that subscript. So you've got to write big. When I try to do this with my equation writer, I have to make the base big, and then I have to put everything, and then I have the exponent, and then I have to make this drop down, but it can't drop down that it's the same level as this guy. Because this whole thing right here, that's an exponent. That's an exponent. Then 5 raised to the log base 5 of 42 is 42, inverse property.